Okay, welcome back. These are the 8.3 notes, inverse trigonometric functions. This is page 3. A reminder up top on the intervals that our ranges are defined on. For inverse sine, the range is going to go from negative pi over 2 to pi over 2. Okay? And so that's how we're reading that. So taking a look at example 4. Inverse sine of square root of 2 over 2. That has to be in quadrant 1. Sine is defined in quadrants 1 and 4, but it's positive in quadrant 1. So the sine of pi over 4 is square root of 2 over 2. So the inverse sine of square root of 2 over 2 is pi over 4. B wants the inverse cosine of negative 1/2. This is a quadrant 2. That's where cosine is negative. So cosine negative in quadrant 2. So the inverse cosine, the angle where cosine is negative 1/2 is 2 pi over 3. C, inverse sine of negative 3 pi over 2. That's going to be a quadrant 4 angle. The sine of 5 pi over 3 is negative square root of 3 over 2. So the inverse sine of negative square root of 3 over 2 is 5 pi over 3. D, inverse tangent is 1. Tangent's going to be positive in quadrant 1 and quadrant 3. The only place in quadrant 1 where cosine and sine are exactly the same, because we can define tangent as sine over cosine, is pi over 4. E, inverse tangent is negative 1. Our inverse tangents are negative in quadrant 4, that's 7 pi over 4. And F, the inverse cosine of negative 3 pi over 2. Again, that's going to be in quadrant 2. The angle where cosine is negative 3 pi over 2 is 5 pi over 6. Okay. And it takes a little while to go back and forth. For now, take a minute to think about what you believe that angle is and then double check with the unit circle. Okay. We can use the calculator to evaluate inverse trig functions. You will notice that your calculator does have a sine, a cosine, and a tangent button. Right above that are the inverse functions. So you're going to click second sine. You're going to go over to mode and make sure that you are in radians for this one. And then we're going to go ahead and click second. And then the sine button. And then our 0.97. And our inverse sine in radians is going to be 1.33 radians. For our degrees, we want to make sure that mode is set to degrees. And we're going to do the same thing. Second sine, which this time I'm going to write as inverse sine as 0.97. And here we get 75.9 degrees, or 9.3. Okay, last piece here. We're asked to solve the triangle. That means find all missing sides and angles. So we can start by finding this third side using the Pythagorean theorem. And the Pythagorean theorem just says the sum of the square of the two sides equals the square of the hypotenuse. So I got x squared plus 9 squared equals 12 squared. 9 squared is 81. 12 squared is 144. X squared has to be 63 when we subtract 81 from both sides. If you are asked for an exact value, we're leaving this square root of 63. If you want an approximate, we're going to plug that into the calculator and get approximately 7.9. Pay attention to whether it's asking for something to 1 decimal place or 2. Then we want to find our missing angle. So we have a theta in here. Okay. This side is opposite, and even though I just found it, I'm not going to use that because in the event that I made a mistake there, I don't want to compound my mistakes. So I'm going to use the two sides that were given, which is the adjacent and the hypotenuse. And I know that the cosine of theta is going to be the length of the adjacent side over the length of the hypotenuse. Okay. Cosine of theta is 9 over 12. And actually, I'm going to move that over just a little bit. I'm given the ratio, I need to find the angle. So we use the inverse function to undo. So I'm basically inverse cosining both sides. So theta is going to be the inverse cosine of 9/12, which reduces to 3/4. I get that that angle is 41.4 degrees. I have got 3 angles in my triangle. I know that all 3 angles have to add to 180 degrees. I've got a right angle in there that takes up 90. So I know to find my last missing angle, I'm just taking 90 and subtracting 41.4. And I get this angle up here is 48.6 degrees.